So starting on this front page, which ones do you want to go through together? Number 3? Okay. 3 and 6. Okay. So number 3, what's our first step always? Everything in terms of sine and cosine, okay? And if you guys could save kind of some of the side chatter, I would appreciate it. So tangent is sine over cosine, right? So this tangent squared of theta, I'm going to make sine squared over cosine squared. And then how could I write secant squared? Good. So that's 1 over cosine squared. Okay. What do I like about how this turned out? Common denominator. Yeah, down there on the bottom, they both have a cosine squared. So I can go ahead and combine these fractions here. I can make this sine squared minus 1 all over cosine squared. So all I really did was sine squared minus 1, and then I still have cosine squared on the bottom. Okay? Now this looks really close to something that we might like, right? If we could make that, say, 1 minus sine squared, then we could do something with it. But that's not the same thing as sine squared minus 1. We need to fix it somehow. And this is what I was talking about. This you probably have not seen before, but this is a trick that gets used in math a lot. I know for sure we'll be seeing this again when we get to the polynomial chapter. If you want to take a subtraction problem and like switch it, you can't just switch it like you can with addition, but you can pull out a negative 1. All right, and watch what's going to happen if I do that. So I'm going to take this right here, and I'm going to take a negative 1 out of everything. And when I say take it out, I really mean divide. What does dividing by a negative 1 do to anything? Yeah, just switches the sign on it, right? So when I divide by a negative 1, this is now going to be a negative sine squared. And then this minus 1 is going to become a plus 1. Okay, sorry, you can't see that because of the glare. And then that negative sine squared plus 1, couldn't I rewrite that as 1 minus sine squared? Does that make sense? So this is really 1 minus sine squared now. Okay, because positive 1, negative sine squared. And what do we know 1 minus sine squared is really equal to? Cosine squared. So now I can say this is negative 1 times cosine squared over cosine squared. And then my cosines can cancel out, and I'm left with just a negative 1. Okay? And so that's where that one should have gone, is just down to negative 1. Questions on that? What was the other one, number 6?
Yeah.
Okay. Number 6. Okay, so secant x minus 1, secant x plus 1. Okay. Well, I don't want to break the mold, so I'm going to go ahead and convert to sines and cosines first. Secant is the reciprocal of cosine. So I'm going to really make this 1 over cosine minus 1, and then 1 over cosine plus 1. Okay. What do you normally do with things like that, where it's 2 parentheses like that? FOIL. Yeah, we're going to have to, like, distribute twice. So when I do 1 over cosine times 1 over cosine, that's really going to give me 1 over cosine squared. Right? Because you would do 1 times 1 and cosine times cosine, which is really just 1 and cosine squared. And then, if you know you're factoring pretty well, you might catch this. Maybe I'll just go ahead and write it out the long way in case you don't see it quite yet. But 1 over cosine times positive 1 is going to give me just a 1 over cosine. And then I'm going to get negative 1 times 1 over cosine, so I'm going to get a negative 1 over cosine. So what's going to end up happening there? Yeah, those are going to end up canceling. Okay? And then on the end, negative 1 times 1 is going to give me just a minus 1. Okay? I'm going to cancel these things in the middle. So now I have 1 over cosine squared minus 1. Now this is a fraction. How can I subtract something from that fraction? What am I going to need? I think you're thinking division. If I was dividing, I would need to multiply by something. What's that, Riley? Common denominator, right? So if I want to really do 1 over cosine squared minus 1, I need that 1 to be written as something over cosine squared, okay? So I'm going to rewrite it. Where's my other color here? I'm going to take this 1 and really think of it as cosine squared over cosine squared. Do you agree that I can take 1 and rewrite it as anything over itself, right? So if I wanted to have a cosine squared on the bottom, I'm going to write it as cosine squared over cosine squared. So when I put these two things together, well, I'm subtracting. There was a minus in there. So it's really going to be 1 minus cosine squared over, and my denominator is just going to be cosine squared. What can I do on the top now?
Sine squared.
That, yeah, 1 minus cosine squared is really sine squared over cosine squared. Tan squared, good. Yeah, sine over cosine is tangent, so that reduces all the way down to just tangent squared. Okay, and this one is negative 1. Fun stuff, right, Quinn?
I got a different answer and I did it.
You got a different answer, though?
Yeah.
Okay, talk me through what you did, and I'll see if I can follow, and if not, I'll come look.
I got to the 1 over cosine squared minus 1.
Yep.
And I just multiplied both sides by cosine squared.
Okay.
So then it was cosine squared over cosine squared minus cosine squared. So it was 1 minus cosine squared.
Okay, the problem with doing that, with what you just said, was you can only multiply on both sides if you have it, like, equal to something. Like, you can't just take an expression and multiply both of them by something and have it stay the same. I think you're thinking of, and I'll just use the bottom of this paper here, if you had, like, 1 over cosine squared equals negative 1, then you could multiply both sides because there's an equality there. But if you just have an expression, you can't multiply the two pieces by anything. Like, you can multiply by, like, cosine over cosine because that's equal to 1, and multiplying by 1 doesn't change anything. But you can't multiply both sides of one expression. Does that make sense?
Like y number 3 could be multiplied by negative 4.
This here?
Yeah.
So I wasn't really multiplying by that negative number. I was pulling that negative number out. So, like, I just took this sine squared minus 1 and really I factored it. So like, if you distributed this negative 1 back in there, negative 1 times negative sine squared would give you sine squared, and negative 1 times positive 1 would give you the minus 1. So I didn't like add that negative 1 in there. I pulled it out of what was already there. Does that difference make sense? Okay. Okay, anything else here in the front that we want to look at? Lauren, how you doing? Okay. Second page. Anything here? Oh, it looks like I was scribbling my way through one there. So there's that one. Anything here that you want to look at? 13? Okay. So this one's all already in terms of sines and cosines, so I don't have anything I can change there. Okay, I don't have any, like, equivalencies I'm going to put in. What could I substitute, though? Looking at 13. Okay, so there on the bottom, 1 minus cosine squared can really become sine squared. So I can make this sine of x, I always forget and put my x's in, but over sine squared x. And just so you know, that sine squared x, that's really the same thing as this. Here's the top. Sine times cosine. And sine squared I could rewrite as sine times sine. Right? I don't know that you would necessarily have to write it that way, but just so you understand what you're doing when we take this next step. What can I do now? Cross out a set of signs, right? And so then I have cosine over sine, which is equivalent to, that's cotangent. Good. So we land at cotangent of x. Okay? Good with that? Anything else on this page, Riley? Sure. Okay, so first thing I would probably do is take that secant and turn it into something with cosines. So I'm going to make this cosine times 1 over cosine minus cosine. What am I going to do with this cosine out front? Distribute. Yeah, distribute that cosine. What's cosine times 1 over cosine? Cosine over cosine, which is really 1. Good. Yeah, cosine times 1 over cosine is going to just become a 1. And then cosine times cosine gives me cosine squared.
Which is sine squared.
Yep, and there's our friend again, right? So 1 minus cosine squared is sine squared. Okay. Others at all? I think we did 12 together in class, didn't we?
Yeah.
I think we did. Okay, how about here? What here do you want to see, Travis?
Number 5.
Number 5? Okay. Cosine x plus tan x sine x, looking at 5.
You do 6.
You ready? Sure.
Wait, any of them on?
Looking at, I'm going to do number 5,
Oh,
and then number 6, and then I'll take any others that you want to see.
7.
Okay, got it. Okay, number 5, first thing I would do is take that tangent and make it sine over cosine, right? So I'm going to go cosine. This page was not really formatted well for this, but we'll make it work. Oh yeah, this one is going to be a little weird, isn't it? Okay. Let's go ahead and multiply this together. What's that going to give me?
Sine squared over cosine.
Good. Yeah, you're really just multiplying on the top because remember there's like a 1 down there. All right. So that's my first cosine. And then I'm going to have sine squared over cosine. Okay. Now I need a common denominator. All right. How could I write cosine as something over cosine? Braden? Good. Yeah. So really what I'm doing is this right now is cosine over 1. I want to multiply by cosine on top and bottom. Which, this is what I was mentioning earlier when I was answering Quinn's question, is it's okay for me to multiply by cosine on top and bottom of a fraction because really then what I'm doing is multiplying by 1, right? I'm not actually changing the value there. So up on the top there, I would end up with cosine squared, and that would be over cosine, plus sine squared over cosine, which means I can put those together. Let's see, I'll go down here and then I'll just find another spot for number 6. I can add together the top, so I can say cosine squared plus sine squared. And it would just be over cosine. Any thoughts about what to do? Oh, I'm sorry, I didn't realize that was off the page. Any thoughts about what to do now? Does the top of that fraction look familiar to anyone? It's 1, right? Cosine squared plus sine squared is just 1. So this right here can be replaced with a 1. So this becomes 1 over cosine. And what do we call 1 over cosine? Secant. So all of that, and this all just boils down to secant.
What if we don't put the x?
What's that?
What if we don't put the x at the x?
Oh, I don't care. Yeah, we talked about that a little bit yesterday.
What did I do?
What did you do?
I
You got that. get this.
Oh.
You right here, when you added these together, this shouldn't have become a square. This should have just been a cosine x. That cosine wasn't squared to begin with. And like when you add them, the denominator stays the same.
Yeah.
So this would just be a regular cosine x.
Oh.
And that's,
And I didn't get so
okay, so it's not, and this is kind of what Quinn is doing too. You don't multiply both sides by cosine, you multiply top and bottom by cosine of this fraction.
Oh,
Because then you're really multiplying by one.
Oh, I get it. Okay.
Yeah, that's how you got that.
Thank you.
Okay, number 6. I might take number 6 on the back here. So sine cubed plus sine cosine squared. Okay, will you double check and make sure I copied number 6 correctly?
Yes.
Does that look right?
Yes.
Okay. I think we did one of these together, or similar to it. We ready? I think we did. I don't remember. What do those two pieces have in, so first of all, my sines and cosines all taken care of, right? It's all in terms of sine and cosine already. What do those two things have in common? This piece and this piece, what do they share? They both have sine. So what does that allow us to do? Yeah, we can take a sign out. We can factor out a sign. So this is where I'm doing like the reverse of the distributive property. So I'm going to put a sign on the outside of some parentheses. And then what would I be left with here? Sine squared. Good. Yep. Well, that works out nicely. And then when I take a sign out of this chunk, that sign's gone, so I'll just be left with cosine squared. Why do I like that? It's 1. Yeah, this whole parenthesis piece, sine squared plus cosine squared is really just 1. So we just ended up with sine times 1. I don't think you would really have to write that as its own step, but sine times 1, which is just sine of, I don't remember if this was x or whatever. There we go. That was it for 6. Did I hear, Sierra, did you ask for what? 7? Okay. Let's look at 7. Okay. Cosecant x minus sine x over cosecant. Okay. I'm actually going to break the mold a little bit here just to save us some writing. As soon as you guys are ready to listen. On number 7, before I switch to sines and cosines, just because I'm going to end up with a lot of like fractions inside fractions, I'm going to take this thing and split it up. You know how back here, like for example, we were able to take 2 fractions with common denominators and put it together? I'm going to do the opposite. I'm going to take something like this and split it into 2 different fractions, okay? So I'm going to take this thing back apart. I'm going to make this cosecant over cosecant minus sine over cosecant. You okay with that? Okay, taking that addition apart. I am going to switch to sines and cosines in just a second, but before I do that, what do you see here? Yeah, cancels, but it really makes a what? Yeah, so don't forget that that really, it doesn't like disappear. It's really a 1, okay? So I'm going to make this 1 minus, and now I'm going to go ahead and turn that into sine over, and then cosecant is the reciprocal of sine. So I'm going to make this 1 over sine. Okay, when you're dividing by a fraction, what do we actually do? Multiply by the reciprocal. So this piece right here, I'm going to kind of move off to the side and do this. This is really sine from the top times the reciprocal of the bottom, so that would be sine over 1. What happens when I do sine times sine over 1? Sine squared. Yep, so this whole circle is now a sine squared. 1 minus sine squared, which we know is cosine squared. Okay? How are we doing?
Good.
Maybe better than we were before? Okay. All right, so today we're kind of continuing this theme. You can go ahead, leave this out on your desk because I might refer back to some of these, but take your notes out.